In today's video, we are going to look at network management. More specifically, we will look at the Simple Network Management Protocol, SNMP. There are a couple of reasons why we are going to look at this protocol, or at the very notion of network management. Firstly, it makes sense that if you have a network, you might as well use that network to manage the network. Why have this network in place and then expect technicians, other people, to walk around from node to node if configuration changes need to be applied, or if you want to extract information about the operation of that node? The other reasons why we want to look at network management is the fact that it illustrates to us where the limitations of the client-server model are, and how we can get around those and begin to ask ourselves whether the workarounds indeed do solve the problems that we experience with it. The Network Management Protocol is also an example of a protocol that exists purely because the network exists, not because we as humans want to use it for some useful purpose beyond the network. So it's the last of these protocols that we will discuss that are intended for the network, application layer protocols that do not provide end-user functionality. There are obviously many more protocols that fit into this category, but time only allows us to give you a sample of those, and therefore we have selected the tiny sample that we have selected in this series. In order to manage a network, one essentially has to do two things. One has to monitor, in other words, observe what is going on, and that can be done by a form of inspection, going to look at what's going on. And in addition to the monitoring, the second thing is one has to configure or reconfigure, make changes to the state of the network so that it performs better or so that it is fixed where it was broken. The SNMP protocol is the example of monitoring of a management protocol that, as we said, we will consider. And the manner in which that protocol works, and most similar protocols for that matter, is that they tend to have a notion of variables. So all sorts of variables that relate to an item in the network that is being managed. So a managed object clearly has some values that are meaningful for that object. If you think about the printer, then something like how much paper do we have in the printer? How much toner do we have left in the printer? Is there a paper jam? Is there some other need to intervene? Those are things that would make sense for a printer, and we can in principle then define variables for that printer where we say something like paper level, toner level, and type of error in case there is an error. On the other hand, a router may be extremely busy in terms of traffic, or it may not. Specific links may be very busy, or they may be freely available. So in that case, amongst all the other variables that we may be interested in, may be the amount of traffic, given the capacity of the link, the amount of traffic that it is currently carrying. So in that manner, then one has to look at the various objects that make up the network and decide on which variables are going to be influential for that object. In some manner, this is hopefully standardized to a degree at least, and if one goes and looks at how it is done in SNMP, and in fact in a number of related protocols, there is a hierarchy of variables And that hierarchy is known as the management information base. Some other protocols may use different terms for it, but the notions are pretty similar. And one then gets various layers of this hierarchy, and the various layers are standardized by different parties. The International Standards Organization may be rather active higher up, whereas as you move lower and lower down, it may be organizations like, let's say, the IEEE that define standards for local area networks that form a subcategory of this bigger picture. And when one gets low enough, you may get to individual vendors who supply the variables. So in this big tree structure, the various actors provide often complementary parts of the tree, but in the end, one has this tree of variables that is known as the Management Information Base, the MIB. Now, in order to manage the network remotely, the simplest thing to do is the monitoring aspect. What happens in this case is that any managed object makes a number of variables available. In fact, it's not the managed object per se that does this, but there is some software running on that managed object that really looks after the local management of that object and collects this information and stores it in a manner in which it can provide it to other parties that find it necessary to obtain those values. And this is known as an agent. So the agent is a software entity that resides on this managed object, and it collects all the relevant information from this managed object, and it provides it to whoever needs it. It may also perform certain calculations in terms of what it gathers. And in fact, sometimes, as we will soon enough see, it may realize that something really needs attention now, and then it needs to take action, not only wait until someone asks for it. But let's leave that discussion for a little while. We'll get back to that pretty soon. On the network management system, so there's a system in place here that has this overview of the network, of what's going on the network. This system asks questions from the various agents. It polls them. It asks the agents, what is this value? What is that value? And it may do that at regular intervals, or it may do that because the user who is using this network management system is asking a specific query, or there may even be some intelligence involved in the sense that it realizes that something is beginning to look worse and it needs to monitor that aspect a bit more closely. Whatever mechanism is used is not important for our discussion. The point is that you have this network management system, and it then collects all the information from all the managed entities. In order to do that, it operates in a client-server fashion. So all these agents at all the managed objects are servers. And whenever this network management system needs to obtain a value, it will simply send a message to that agent, and the agent will return the value of that variable. However, as we've said previously, we also need to be able to reconfigure things. So in some cases, you may not say, I want to know that value. You may want to say, I want to change that value. Let's say, for example, that for whatever reason you want to change the IP address of a node. Now, in terms of network topology, that is something significant. But in principle, at least, if the agent is able to change the IP address, then this network management system can say, change that IP address. It is more likely that we will want to change variables in terms of where traffic is routed so that we can more evenly distribute load and that sort of thing, rather than change specific IP addresses. But in general, we want a smooth flow of traffic through this network, and perhaps changing a routing table would be a much better example of the sort of thing that we may want to do. again, this is done in a client-server fashion. The management software tells the client by way of a request, change that value, and then the agent, acting as the server, responds to the network management system that is acting as the client and says, I made the change that you requested. As long as things are running smoothly, then this regular polling by the network management system of all the various agents in the system should suffice. However, things go wrong unexpectedly very often. When a printer suddenly runs out of paper, it may realize that it has a problem and users are keeping on sending printing jobs to it, and somehow it needs to tell someone to come and add paper to the paper trays. So in that sense, then, we need some sort of a reverse mechanism where an agent can say, I'm not going to wait until I'm polled, I am going to send an alert. And that is implemented as another client-server architecture. So this network management system, which normally acts as the client and it talks to all the agents to say, tell me this, tell me that, or change this, change that. This network management system also acts as a server so that any of the agents can become a client and send a request to it. Now, those requests that are sent to this network management system are known as traps. So when a network agent realizes, I need attention right now, then it will send an alert, and this alert will be sent to the network management system, which then can take immediate action. It obviously depends. There are many network situations that can be corrected online. As we noted earlier, maybe if a network link goes down, changing routes in a routing table may be one means of addressing the problem immediately. However, the example that we've used, a printer running out of paper, is one where manual intervention will be required. And therefore, the trap will be set such that it tells this network management system, this is a problem, and then manual intervention will follow. In fact, to cater for those situations, the network agent may actually send a trap to say, this paper bin is almost empty, so that the manual process of adding paper can be initiated sooner. There are a couple of messages that are used by SNMPs, and it's only a handful of messages, so let's quickly run through them. The first is the GET request. The GET request simply specifies a number of variables, and it sends the names of those variables to the agent. The agent provides the values, and they are returned to the network management system. So it's a simple GET mechanism that is employed. Note that we can get one value or multiple values. Doesn't matter. The second mechanism that is available in SNMP is the SET request. With SET request, one specifies the name of a variable and the associated value. One sends that from the network management system to the agent at the appropriate managed object, and the agent will then change that value in order to reflect whatever has been specified, and it will then simply respond with a message to say that this has been done. Note that in many cases, this SET request will be used to actually set a value, such as to set an entry in a routing table, but we can also use the SET request to affect, let's say, a machine that needs to be rebooted. So if there is a variable reboot somewhere and one writes to it, then the agent may know, okay, that means you want to reboot this node, and it will cause this physical action to happen, the node to be rebooted. It's entirely possible that we can specify variables with these almost side effects so that one can get things done as and when necessary without the need to walk over. So some physical actions can actually be achieved via the network, whereas some others cannot. The next mechanism provided by SNMP is the getNext request. The getNext request is one that is used to traverse the tree at any managed object. So what one would do is typically to ask for the very first item of information, the very first variable at that object, and that will have an object identifier of 0. So one can send a GET request, obtain that one, and then subsequently traverse the tree by issuing getNext requests. Every getNext request will return the name of a variable plus the value associated with that variable. The names are sorted alphabetically or lexicographically, so one would work through them in an alphabetical order, obviously. This is an easy way to discover the variables that are known by the agent at a managed object, and the network management system can then display them for the user to interpret or perhaps make use of them in some other way. After this getNext request, we can look at the getBulk request. The getBulk request is in essence an optimized version of the getNext request, where the getNext request is one that says, give me the next value, give me the next value, give me, and you get one response for every getNext request. You can say getBulk request, and then it will send you a bunch of these getNext request values. So it cuts down on the overhead, since you don't have to send so many requests to get the variables one by one. You send one getBulk request, get a lot of variables back, and then you can interpret them, well, at the very least, know that they exist, and then hopefully try and make some sense of them if possible at all. Next on our list is the trap message. All the previous messages that we spoke about were messages that were sent by the network management system, and the network management system acted as a client to the agent at the managed object, and that server, the agent, would then send a response back to the network management system. When you invert these roles, when the agent says, I want to initiate communication and talk to the network management system, then the trap message is used. So the trap message is part one of a query response message system, but this time it is sent by the agent at the managed object, and it is sent to the management system. This is where the second client-server architecture comes into place. This is where you get them meshed so that you can get bidirectional communication. And this is, as we said earlier, one of the points where the traditional client-server fails, because we need to duplicate this. Keep in mind that normally when we talk about the client-server protocol in the network management protocol, what we are talking about is a server at every managed object. Now we are talking about a server at the network management system, of which there may be one or there may be a few, but probably not many. The trap message will contain a variable, and the variable will have an associated value, and also the type of trap, the type of reason that is being reported as the cause of the problem that this node is experiencing, that the agent is now reporting. The trap messages are also defined in the MIB, so it can be known if you have a full MIB available, you know which traps can be received, and one can set up certain actions to occur when a network management system receives a trap message. The final item on our list is the response. Normally in a client-server environment, one doesn't really talk about the response. You send the request and that is followed by a response. To fully understand what is going on here, one needs to delve down to layer 4, where we will eventually talk about different types of transport layer protocols. Our primary examples will be TCP and UDP. TCP will be an example of a connection-oriented protocol, in other words, one where you establish a connection and then use that connection like a telephone call to talk back and forth. UDP, on the other hand, will be a connectionless protocol where one can send messages pretty much like in a mail system or a postal system. So you send the message, but there's no mechanism in place for the response to be sent back. The response forms a separate message, and that's the reason why the responses are listed separately here. In terms of ports, the Simple Network Management Protocol uses port 161 for normal communication between the network management system and the various agents, and it uses port 162 for trap messages that are sent from the clients to the network management system. Over the years, the Simple Network Management Protocol has seen a number of revisions. Revisions 1 and 2 didn't include much security yet again, so it was fairly open for people to abuse. And one can just imagine if people were starting to abuse the network management system. Number one, you could learn so much about the network. If you were an attacker, then setting up your own little network management system and just to collect information about the network that is being managed, that's lovely from the perspective of an attacker. Often you needed to be inside the network, but we know the insider threat is one of the major threats faced in terms of security. Also, as an attacker, you could potentially change parameters and cause real disruption. So you didn't even need a separate exploit necessarily to attack the network. These two protocols, versions 1 and version 2, used the notion of a community string as one of its primary protection mechanisms. Now, the community string is simply a string that says, I am from this community, and it in a sense works like a password, but it's a widely known password, and more than that, it even defaults to public. So if you don't configure your equipment properly, it may be willing to provide information to the public community, and that's the very first guess any attacker would want to use. In version 3, security has moved from this community level authentication to a level of authentication where we identify individuals. So it uses a mechanism where the name of the user who initiates the request and the password is specified. However, most of these requests are initiated by the network management system, so it is still a matter of getting that password somehow encoded or whatever, hidden in the network management system, and then the password would be sent across the network with the name of the network management system. So it's far from perfect. Also, in version 3 of the protocol, provision is made for encrypting the messages, the requests and the responses, which was not the case in versions 1 and 2. So in 1 and 2, if one sniffed the traffic, one would have been able to learn quite a bit about the information that was being sent between the network management system and the various agents, obviously assuming one had access to an appropriate link or router or something between the network management system and the agents that are being managed. In the case of version 3, this is encrypted, so it decreases the risk. In the little demonstration that will follow soon, you will see how some of these things are implemented, and it will give you a feeling for how simple it can be. However, don't be fooled by the simplicity. Once you start to configure something to use version 3 of the protocol, it becomes quite a bit more involved. We should also note that some companies, and let's specifically mention Microsoft here, has been moving the Simple Network Management Protocol out of its Windows operating system. At some point, it became something optional that you needed to activate. Now it is an optional feature that you have to install before you can use it, and their long-term plans are to completely remove it, precisely due to the security concerns that are inherent in this protocol. I don't know what the plans of other vendors are, but we still have widespread support for this protocol in the community. Perhaps this is also a good place to point out that SNMP is by far not the only protocol available to manage networks, and there are many protocols that are in use, some of them proprietary for the products of a specific manufacturer, some of them dating from mainframe days, and so on. So we do have alternatives if we were to stop using SNMP. But for the time being, SNMP forms an excellent example of many of the points that we wanted to illustrate. Let's now move over to a simple demonstration where we will set up SNMP on an object, on a managed object. And the idea is to show you how easy it can be. Do keep in mind that for other cases it may be much more involved. And then during the second part of the demonstration, we will use a network management system to explore the network, to see how these requests are being reported at a network management system. For this example, I'm going to show you how to enable SNMP on a Synology NAS. It's a network attached storage unit. This happens to be the network attached storage unit on which I am recording these videos while storing them, while editing them at the very least. I'm using this example because it is arguably one of the simpler examples that I've encountered of how you can enable SNMP. There are other options that would involve a lot more effort. In this particular case, this is running DSM. That's the normal operating system that is used by the Synology NASes. And I can click on the control panel. Various things that I can set on the control panel, but if you look at the very last item here that is shown by default is the terminal and SNMP access. So what I can do is click there. It gives me the option to determine whether users should be able to access this NAS using some sort of a terminal. And you can see that the SSH terminal is enabled there, but not Telnet. However, the more important part for our current discussion is SNMP there. And if we click on the appropriate tab, then you will see the various configuration settings that are available. So the very first thing that I can do is simply to say enable SNMP, and then I have a choice amongst various options. There you can see I can activate or enable SNMP version 1 or version 2, specifically version 2C. And for those two, you can see that I can specify a community string. As I said, that community string is the shared password, but in quotes really, because one shouldn't treat these as passwords. It basically says whoever is of this community can now use SNMP. So I can use it as public, which is the default value. If I go to SNMP version 3, then I have to specify a username, because as we said earlier, for SNMP 3, it is no longer based on the community. It is based on an individual user. And then I can pick, in this case, between an MD5 and a Shamir hashing of the password. And then I can specify the password there. Just to re-emphasize something that should be obvious, If I leave it open for SMP version 1 and 3, then they are both supported. That combination and this much improved SNMP version 3. So I have to disable SMP version 1 if I only want to use SNMP 3. If we look at the other options that I can specify, then you can see here that I can specify a name that should be reported via SNMP. If I do not, then it will use the default name of this device, which you will see soon enough. And I can also specify the device location, which is very useful. For example, if you are managing, let's say, a campus-wide network spread across a university, to know exactly where the item is that is causing a problem, if it does need attention. Or if there is an individual person who can be contacted about a problem with this device. Let's say someone who can go and add paper to a printer, then I can provide contact details there. I'm not going to do that in this case. I'm rather just going to use the default values. Just before we step away from these settings, note that I can also, as noted earlier, encrypt the information that is being sent across the network so that eavesdroppers cannot see what I'm communicating. And the options that are supported here are AES and DES. And then I simply specify the password to be used. Clearly shared key password, so I have to set it up here on this agent that I'm busy configuring, but I also have to set it up on the network management system so that it can understand the value. So somewhat of a key management issue here, in the sense that I have to get the same password specified at all the agents in my organization. Less than perfect, but at the very least there is a mechanism to implement encryption. For the demonstration, I am going to use, as we so often do, the simpler version, and I'm going to use that particular setting, and we will see this again in a moment or two in a network management system. For this demonstration, I'm going to use LibreNMS, the Libre Network Management System. This is not a system that I know. It is one that I found very recently and thought it would work well to demonstrate the operation of a network management system. So we're going to use it, and it will hopefully serve as a demonstration of what we are talking about. What you can see on the current screen that is being displayed are all the devices that I've added to this network management system. Now, I could have added many more devices, but that would just have cluttered the display, and you will soon enough see that there is enough clutter already when we go into some of these devices. What we note immediately here is that there are names of various devices, and as I moved the mouse cursor over them, it attempted to display me little graphs just to show me what's going on inside that particular device. So let's quickly do that just to give you a feeling for what it looks like, but it's not going to be very useful. So if I hold it on the printer, then you can see that I see some graphs, and the one graph is just for use on Sunday, and then there's another one for Monday, and I've been running this since Sunday, so the next graph is one that provides me some information about the previous week, and you can only see activity in the last 2 days because that's the only place when I used it. Exactly what the details are we can see when we click on the particular device, which we will do in a moment or two. One of the principles in any network management system is that you want to identify things where there are issues as quickly as possible. So here we are looking at all our devices, and you can see that quite a number of them have a green line at the beginning. Basically says everything's fine on that machine, but then there's an orange one, there's an orange one, and there's an orange one, which tells us that we may need to look at those. There are things happening there. At least they're not red, they're not telling us that there are serious problems there. Here we can see the number of messages and so on. We can also see the number of metrics. So for that very first one that happens to be a printer, there are 4 metrics that are being reported. We'll see the details of that just now. Over here we can see how long these devices have been up, and some of them have been running for 3 months without going down. Some of them have actually been up for a long time, but the network management system only registered them as being up from the point that the network management system saw it. There you can see the location that we configured on the agent, on the Synology NAS. You can see a number of them are unknown, a number of them are blank. In fact, if you look at what we did on the Synology NAS, we left it blank and it is reported as unknown. And there's another Synology NAS here which is also reported as unknown. But we can easily fix that if we wanted to. However, I do know where my NASs are, so it's of little use for me. Let's go into one of the devices. And the first one that I'm going to go into is the printer. And on the printer, you can see some information being reported about the printer, how long it's been up, and some number that identifies it in the system, and so on, the brand of the printer. In terms of monitoring, over here in the top right hand corner you can see the CPU activity, and clearly over this monitoring period I've not printed anything. There's been no CPU activity. Scrolling down on the left hand side, you can see the overall traffic that has flowed into that printer and from that printer, and it's 80 kilobytes, so probably mostly the network management system and a couple of other monitoring systems that are keeping an eye on it, that's causing that traffic. On the right hand side you can see that the memory of the printer is used about 59% at the moment. It's a bit high perhaps, but one needs to monitor that over time to see whether that is really an issue. If it stays around 60%, then it's not a problem. But if when we start to print seriously, it goes up and down, and it often reaches 100% or gets close to 100%, then we know that there is a problem. You can see the red color being used here, and again, the moment that I hover over it, I get the graph that shows me what's happened in the past couple of hours, in the past week, in the past month, and in the past year. So disappears completely when one goes to the final graph, which actually goes from more or less June of last year to April of this year. Moving down, here we see a serious issue. You can see that the toner is at 8%. Again, the moment that I hover my mouse over it, I can see the history. And again, because I've been running this network management for such a short period, I don't have a meaningful history. But if I had been running this for over a year, let's say, or a couple of months even, then I would have seen how my toner declined. So I would have been able to determine the rate at which I'm using the toner, and that would tell me at what time do I need to replace it. I know that 8% of toner left is dangerously low. It's already when you are starting to print things that contain a lot of black, then you can see some tiny white smudges, and that's going to increase. So I know about this issue. My new toner is on order, but that's precisely why one needs this sort of system to warn you that this is happening. I can also see this in the printer interface that the printer itself provides, and the status light on the printer is flashing red, so I'm getting messages from all over the place that there is an issue with the printer. Now, how I will discover this using the network management system should become clear very soon. Scrolling down a little bit, we can see that there are other elements. The fuser is at 82%, tray 1 roller and the tray 1 torque limiter are at 95% and 85% respectively. So they should last quite a couple of years into the future. I've been using this printer for a few years now, and I've hardly touched those elements of the printer clearly. So that should last for a long time to come. Yet again, ideally I want a graph, and if it stays more or less constant over a period of months, then I know that's not really declining. It also tells me that tray 1 is filled with about 50% of paper, so I know it's full enough for the time being. I don't need to take any steps now. And then there's also a manual feed tray, which is typically used to feed single sheets. And it tells me that that is empty. I don't have any paper that I'm feeding there. So that's causing an issue, but it's not a real issue. So this is an example of something that I'd prefer to switch off. Don't know how to do it in this network management system yet, but clearly I don't want that monitored. It shouldn't even report that to me. I'm not concerned about that. Looking at the state, you can see the device status is reported as a warning state, and the printer error status is reported as critical. There are multiple issues, and one of them is that MP tray, which I said previously I don't really care about. So arguably, if I turned that off, the printer error status would change slightly. And then I also get a count here. Since I switched my printer on last, I haven't printed a single sheet yet, but over the years I have printed 16,000 pages with it. So that gives me the sort of information that I can use. Again, if I begin to look at the graph, then I can see how I used it over many years, and whether there are specific times when I use it much more than other times, and so on. There's a little log at the bottom, and I'm not going to go through that log. But the idea of all of this is that this gives you an indication of the sort of information that I can get when I inspect a device. So this happens to be a printer. If I go to my devices, I can tell it that I want to look at all devices. That was what we saw on the screen that we started with. I can tell it that I want to look at the network devices, in other words, the switches and the routers and so on, that I want to look at the printers, that I want to look at the servers, or that I want to look at the storage devices. Now, let's pick the storage devices just to give you an example of what we see from the device that we've configured earlier in this video. And that's the one that we configured earlier in this video. And that particular one has been running for 27 days now. In fact, when I upgraded it, I did not power it down. So I upgraded it about a week ago, and I just inserted a new disk in it, and it reconfigured itself without the need to power down. That's one of the beauty of using a NAS. So let's go into this and look at the information that we get from this. What we see here are, again, various entries about the name of this device, its serial number, who should be contacted if there are any issues, when was it added. Now, that was added to the network management system, not added to the network, and how long it's been up and so on. We can even go and look at it on a map if we want to. The other variables that are reported on the right-hand side of the screen at the top, you can see the processor usage on that device. You can see there that there's not much usage occurring right now. The overall traffic that is flowing, you can see that there was some traffic flowing on Sunday afternoon, and now that I'm recording this on Monday, there's again a little bit of traffic flowing, but I'm not recording to it as such, so that's why we're not seeing much there. Let's rather go to the values that are reported here, the individual values. And you can see that most of them are green or blue, so I immediately know that there's no real problem. The swap space, for example, was running at about 2%, so it's not a big deal. Scrolling down, we can look at the storage available on that particular device. And again, most of the entries in green, so not an issue at all. Volume 1 is sitting at 52%. I referred to an upgrade earlier, so it was sitting at about 90%. I bought another disk and inserted it into the NAS, and that's why the storage space on it more or less doubled, and I am now only at 52%. So time for growth, but still it's already indicating it as brownish. It's not something that is sitting there unused. At the moment, I have 3 disks that are plugged into it. You can see the temperatures at which the disks are running: 37 degrees, 39 degrees, 28 degrees, and the system itself is running at 42 degrees, all in green, so I know that that is not a big deal. These drives, if I go down a little bit more, these drives are operating normally, so none of them is about to fail. And they are configured in a RAID configuration, so I do have the speed and redundancy protection that I want over them, and then other information about the fan, the power and system. It's all green, so I don't have to worry. I know I don't have to worry about that at all. And there's even an upgrade available, and it indicates that to me in orange. So I can go and upgrade it if I want to. The way in which I'm using this at the moment is I am inspecting individual devices. In a large corporate setup, we have thousands of devices. This is not the sort of thing that you will do. You will not sit down and look at these devices one by one and see, okay, my physical memory seems to be an issue there. What you do want is an overview of how your system is performing. And the way in which we can do that is to go and look at that health entry at the top there. And as we add things, that health list will grow. I can click on health and then select a specific item. Now, if I select toner, which was added to this list after I installed the printer or after I connected the printer to the network management system, I know my toner is low. So let's just click on that and get some sort of feeling of how that is reported. And as you can see there, immediately in red, I can see that my black toner is becoming an issue. And then again, that MP tray, which isn't really an issue, and everything else seems to be more or less fine. If I had multiple printers connected, and I do have multiple printers here, but I have not connected the others to the network management system here, I would be able at a single glance to see for all of them where the toner was getting low, or perhaps for some of them where the ink level was getting low. Going back to the health, we can also look at processor load, and there we can see that the processors that I'm currently monitoring are not really busy. The only one that is busy, 28%, so it's not very busy, is the one on the Windows computer on which I am recording this particular video. So that seems fine. If I look at memory, then that is much more of a mixed picture, and I may now want to go through this list and look at the red ones. However, this being a network management system, I don't want to look through potentially hundreds or even thousands of devices. I just want to say, sort them for me, and if I sort them from high to low, then I immediately get that one at the top of the list. The virtual memory on my router is rather full, 82%. Now, I'm not sure why this is happening, because my network is not very busy at the moment. Maybe something is upgrading at the moment, something like that. I can yet again go and look at the graphs over time and see whether that is a constant problem, or whether that's just the normal situation, or whether it is something that deserves my attention. Scrolling down, there is the local host. That's the virtual machine on which I'm running this network management system. That is reported as a problem. You can see on the graph that is displayed there even that it is being increased. However, at the moment the usage is only 24%. So that may be worth investigating, why it is displaying it in red. Everything else is displayed in green, so probably not too much reason for concern. Let's just quickly look at some of the other things here, such as state. And again, we can see that most of the things on the network are operating pretty normally. I do have issues on the printer. Again, that critical message. The bottom line with all the scrolling is that I can easily check things like the memory, things like the processor, things like the storage. In this way, I can fairly easily monitor the things in my network that need attention. Note again that if I enabled alerts, which I have not, then the devices would also be able to send critical information through to me, and I will immediately get an alert, and I can even set up some alert rules so that it should perhaps send me an SMS or an email or something if an alert is reported. In the end, it is much easier now to look at a network that, as I noted, may consist of thousands of nodes, and just not worry about the things that are in green, and get the issues, the health issues that are reported in red right to the top, so that I am immediately aware of where the issues in my network are. One of the interesting things to note on this page, where we have set up the Synology NAS to use SNMP, we see at the bottom of this page that there is a link to the Synology website, where it provides us with more information about the Synology part of the MIB, of the Management Information Base. Recall that the Management Information Base is this hierarchical structure of variables that are available to query when you query a device for management information. Now, clicking on that link takes one to a manual that discusses in rather technical but very brief terms the use of the Synology MIB in certain variants of the Synology NAS. There's also a link there that one can click on, and once we've clicked on that, we can go to the actual MIB as defined by Synology. What one downloads there is a zip file, and once it is unzipped, you get the files that you can see on the screen right now. The name should be relatively self-explanatory. So the disk MIB should contain information about disks that may be of use. and the port may be containing information about ports that are useful, and services, information about services that are provided by this NAS, and so on. Let's look at one of them to get a feeling for what's going on in there. Now, this is on a Windows machine, so type is the appropriate command to use. And if I just type the disk information, so the disk part of the MIB, and I pipe it via less, so I have less on my machine. If you're using standard Windows, you'll be using more because less is not provided by Windows. In it, you will see that we have a set of definitions that begin over there. The actual notation used here is ASN1, Abstract Syntax Notation 1. Once we get to layer 6, we will say more about ASN1. It is a fairly commonly used notation that is used to describe the syntax of entities. What we see are a couple of almost header-like information about the module identity and so on. Don't want to go into details there, but if we go down in this list for just a little bit, then you will see that we, for example, define a disk table there. Well, not we, Synology does, and they define it as an object type, and syntactically it is a sequence of disk entries, and then it provides some other information about it. There is the disk entry defined, and it is defined as a sequence, an array. And that array is an array that for each entry consists of a disk index that happens to be a 32-bit integer, and then there is also information about a disk model, which is an octet string, basically a character string that says more about the model. And then the disk type is another octet string, and then there is a disk status that happens to be a 32-bit integer, and the disk temperature that happens to be a 32-bit integer. And so we can go through this and see the various aspects defined as we go down. In the end, what this does is it exposes these variables that we are defining here, these entries in the tree really, that exist as variables that the agent on the Synology NAS know about. It exposes those to the network management system, and we are able to access them from the network management system once we have imported this part of the MIB. In other words, the network management system will not necessarily know about this particular MIB, and we may have to import it. And the same for other vendor-provided MIBs. We may have to import them to make them accessible to the network management system. But once we have, we are able to access all these various entries that it defines, and certainly some of them will be of value. In this video, we discussed network management protocols. In general, network management protocols face the challenge that sometimes you want to initiate a request from a network management machine, and sometimes you want to initiate it from the device or the object that is being managed. We used the simple network management protocol as our example. However, it should be noted that the simple network management protocol is by far not the only one used in this context. Arguably, there are more contesters in this area than we find in many of the other areas that we discussed. With the simple mail transfer protocol, you won't find many alternatives that are in use. But with network management, you do find quite a couple of alternatives. I guess some of the reason for this variety is that network management protocols were important even in the days of mainframes, well before we saw the introduction of TCP/IP. In addition, the simple network management protocol is one that suffers from quite a couple of security drawbacks. And there are reasons why organizations are hesitant to deploy it. I'll leave it up to you to look at the innovations that were added by version 3 of the protocol to decide whether that is sufficient to secure it, or whether the path, as we've already said, that Microsoft is following by moving away from SNMP for their Windows computers is the appropriate course of action. Just one word of warning in terms of terminology. The simple network management protocol is very often confused with the simple mail transfer protocol, SNMP and SMTP. These two are so close together that in an examination, students often tend to write the one when they wanted to write the other. So be very careful and double check whenever you use either of these two protocols. In our next video, we will look at a number of other application layer protocols that are, for some reason or another, interesting because they do not follow the rules as one would have expected them to follow.
Music